All right, welcome back. So now, in this lecture, we're going to talk about error handling. So we've talked about this a little bit through the course of the class so far, in that sometimes bad things happen. They're generally because of your users. So if you provide detailed instructions on what users are supposed to do when they use your code, you can be almost guaranteed that there's some user out there who's not going to read those instructions and is going to use your program improperly. You're going to be expecting a shapefile and they're going to give you an image. You're going to be expecting numbers and they're going to give you text. So what we have to do as programmers is be able to handle this in some way. There's different ways that you can handle it. So you can show them a message that says, "Idiot, you just gave me the wrong thing." Or you can handle, so that's not silent error handling. You inform the user what they did wrong, hopefully some instructions on what to do to correct it. Or you can do silent error handling, where you just keep rolling. You swallow the error as it's known. You don't tell the user that an error occurred, and you just keep rolling. So you can have those two different scenarios based on what kind of program you're writing. If you're writing a script that takes a CSV file, parses it, turns it into latitude, longitude, and somebody doesn't give you latitude, longitude, you might prompt them with an error that says, "Dummy, give me some latitude and longitude if you want me to process this file with my code." If you're writing Windows, for example, there's a gazillion errors that happen all the time, but Windows has to keep running. So those ones generally fail silently. They add to the system event log that an error occurred, but all of Windows doesn't shut down. Right? So there are instances where you want to fail silently. There are instances where you don't want to fail silently, where you would prefer to inform the user that a problem occurred and that they need to fix it. So we're going to look at how Python does error handling. There are multiple kinds of errors that you will run into. The Python editors, such as what we're using, Visual Studio Code or PyCharm, will handle some of these for you as you're writing your code, right? So if you have written incorrect syntax, or if you have a function that you try to call which is not defined, or you spell something wrong, or you use wrong parameters into a function, it usually highlights it in red, indicating to you that in big red underline, something is wrong here. You have a syntax error. So if we had this tiny little piece of code here where we are trying to make a file just called exception.py, and in it the only thing we wanted to do is print hello, standard hello world style, but we spell print wrong and we try to run it, it's going to underline it, telling us that there is a syntax error, but we try to run anyway because this is Wild West and we do what we want. If you try to run it anyway, it's going to tell you that name print is not defined, right? So PRIINT is not anything that Python knows about at this point. So it's thinking you're trying to call a function named PRIINT, which doesn't exist anywhere that it knows about. So it tells you name print is not defined. So function named print is not defined. So this is sort of the simplest error. This is you being a bad programmer error, and Visual Studio Code was trying to warn you as much as possible that you're about to do something wrong, because you are referencing a function that it doesn't know about. So please don't do this, please don't do this. But when you try to run it anyway, Python will tell you you got yourself a name error. So that is programmer problem. Solution to that: be better programmer. Don't misspell things. Don't try to call functions that don't exist. Make sure you write valid code. Okay. More common errors that you're going to run into are you have developed correct Python code. Your code should work and compile, but something outside of your code is not working properly. It could be that you are trying to reference a file and you expect it to be in one place, but you developed it on Windows, and now you have a Linux user using it, so the path names are all messed up, and there's no c:/users anymore. It's something else. So the file is where you thought it was going to be does not exist. So Python tries to open a file, can't find it, and it provides you back an error saying file not found. It could be you are asking the user for input from the command line with the input function, and you ask them, give me a number between 1 and 10, and they enter the word hello. And then when you try to convert the word hello into an int for your loop, now Python don't know what to do if you give it the word hello and say, please convert this to an integer. So it's going to say type error, can't create object of that type from what you gave it. So this is most of the errors that you're going to run into is when you are asking the user for something and they give you the wrong thing. So we've seen syntax errors, we've seen user input errors, then there's also some logic errors where you wrote valid Python, like it ran just fine, there's no red underlines, but you're trying to access the index of an array which is beyond how big your array is. That's a very common one that you'll run into as well. So that one will give you index array out of bounds exception. So all of these different types of exceptions can occur, some for stupid reasons, some for user reasons, some for logic reasons. And Python, just like every other programming language, allows you to do what's called trying and catching of those exceptions. So what do these things look like? The structure is the word try, colon, and then indented or tabbed because it's Python, the thing you think that might cause an error, and then the word except, and optionally a type of exception or not, and then a colon, and then what you want to happen when that exception occurs. So if the exception does not occur, file opens just fine and it keeps running. So what is ever in your except block, or blocks as we'll see in a second, because you can have more than one, whatever is in your except block only gets run if that particular type of exception is found or is generated. If that exception is not generated, this code is not run. So what you want to do is if you think you have risky code that might cause an exception, like anytime you read a file, for example, you wrap it in a try except block. So if an exception occurs during any of that risky code, you have now handled it. Like your code is going to break because you're not going to have the file that you wanted open, but at least you can provide the user with an indication that your code has now broken, and here is why it broke. In this particular case, it would be a file not found error, so you tell them file not found. So as we see here in this little screenshot here, Python usually does a good job of telling you what the problem was. Right? So if it can't find a file, it's going to tell you file not found, no such file or directory. So when you're trying to debug errors, you should read them as step number one. They are often pretty good and tell you exactly what the problem was. So if you start asking for help from your TAs or instructors or whoever, and they point you to what did the error say, and the error says file not found, they're going to tell you file not found, maybe you should diagnose why the file is not where you think it is supposed to be. So reading the errors is step number one of solving the errors. You would be surprised at how many people don't do that and immediately just start emailing professors. If you get let me Google that for you, or if you get did you read the error that got printed out, if you get those as your responses from your instructor, you are pissing people off, because you should be able to read and Google yourself. As an adult who is a programmer, like this is what you're going to have to do for the rest of your programming career, is troubleshoot on your own. And that starts with reading the error message and Googling the exact error message to see what caused it. But enough yelling at you. All right. So there are many different ways that you can structure your try except blocks. You can have a specific error that you were looking for, or you can have catch all errors. So if you use the word except space and then a particular type of error, which would either be a built-in Python error or a error class that you create, then it's only going to catch that one particular type of error. So here we're looking for a file, and it's only going to look for, or it's only going to be able to handle file not found errors. There's file not accessible errors where somebody else has it open for writing and you're trying to read from it. That's going to be a different error. There's I/O errors, there's syntax errors, there's all kinds of different errors. So you can set up your code where you only check for specific types of errors and handle them uniquely, or you can do the other way, which is catch all errors. So if you don't have a specific name of error after the word except, then it's going to catch any kind of error that occurred. So there's reasons to do both. You might also chain them together, which we'll see in a second, a little bit lower, so that way you can handle different types of errors differently. Or you might just want to catch any kind of error and handle it generically as error occurred. So file not found error is one. Another type of error that you might see is an end of file error. So an end of file error happens when you open and read to the end of a file. It's possible that if you use these improperly, it would trigger this one if you don't have this one listed, right? So if you try to open a file and you're only trying to catch the end of file error, that will get caught, because if it can't open or find a file, then it's also not going to be able to read to the end of the file. So this one will occur even if you don't have this one, right? So what was actually happening was that the file not found error was occurring, but since you can't find it, you also can't read to the end of it. You have to be careful about the order with which you do these, right? So we can link a bunch of these together. So we can have first try to catch an error about input output, then try to catch a file not found error, then try to catch all errors. So if it's not an end of file and not a file not found, but it's some other kind of error happening, putting them in a list like this in order, this will catch everything else. So this is useful if you think that you might get multiple different types of errors, right? So if you're writing a program that tells a user enter a value between 0 and 10. One type of error is that they enter a string, not a number. So you could handle that error. Another would be if they entered a value outside of the range between 0 and 10. So you could handle that error secondly. A third would be if they hit Control-C to cancel the program. That raises an error in your code, and you might want to handle that and do a goodbye message. So you can have as many of these as you would like and handle each different specific type of error uniquely in a way that provides information to the user to let them know that something has occurred and this is exactly what occurred. Again, the code that's inside of each of these accepts only runs if that particular type of error, or any other type of error occurs. So if there are no errors, none of this is going to run, right? So you might be thinking, oh man, this is a pain. I got to write all these error handling, which isn't going to run most of the time. This is true, but when you need it and you need to present the user back with information about what they did wrong or what is happening that is making your code not run, it's helpful to have in there, right? There is one additional construct in your try except blocks called finally. So finally happens upon success. So if the thing that occurred in your try block runs, then and only then will the things inside of the finally block run, right? So if we make a variable named file and we try to open it, cool, we now have this file open. Right? So good programming, as we remember from our file lecture, is to always close your files so that way you don't have dangling references and you don't prevent other people from being able to access them. if your file is still open by you. So at this point, if this succeeds, our file is now open, right? So you can imagine that there's some more code in there to do stuff with file, and then at the end, we want to close our file. But we only want to call file.close if we succeeded in opening it. So if we were unsuccessful, one of these errors would have happened, and our file is not open, right? So if an exception occurs on this line trying to open the file, it means file did not actually open. So if we were to try to run file.close on a not open file, it's going to give us another error. So the things that we only want to do if this file opening was successful, such as close the file, go into the finally block here, right? So if you didn't have this inside of a finally block and you just had it out here as some other part of the code, it would have thrown an exception if the file were not open. So if we had an exception that caused the file not to open, but now we try to close it down here, it's going to throw an exception. So this is the general structure of your try, except, finally blocks. Thing that you think is risky inside of try, all the ways that you're going to handle a variety of exceptions, and then the things you want to occur if the try succeeded inside of the finally. So this is a very short intro to exception handling. I guess in a nutshell, you have syntax errors, and then you have actual exceptions that occur based on inputs and outputs to your program. We don't have a whole little section in here about logic errors, but you can run into logic errors if you most commonly try to access the index of a collection. Like if you say collection 100, meaning give me the thing at index 100, but your collection only has 25 things in it. So those are logic errors that occur because you thought incorrectly, or there's a situation that occurred inside of your code where your indexes are different lengths than what you were expecting them to be. So the way you handle all exceptions, any one of these, is with try except. And key parts here is that you have what you think is risky inside of the try. Then you have a series of except clauses. They can be specific type of exceptions, or they can be all other exceptions which were not specifically identified. You don't have to have specific ones. You can just have the general except. And then you have a finally, which is the things you want to occur if and only if your try block, all the code that was inside of this try colon indent, next line, succeeded. So that is exception handling. Real short. Exception handling is extremely useful. It helps with debugging. It helps your user understand what they're doing improperly and why your code keeps failing. And you're going to have to decide if you would like to present messages back to the user and or crash the whole program, or if you want to fail silently and just keep rolling and not inform the user that an error occurred. And there's cases for both of those. So that's it for exception handling.